You can't see anything, but I've got it. Sorry. So, anything in particular you guys want to know about the test to start with? Did you even have a chance to look over the outline yet? Okay. Anything up there jump out at you that maybe you want to talk about first? Because I know we're probably not going to have time to just do 15 questions. You know, some of them are kind of repeated, like natural log and log base. These are sort of the same questions. The main difference being natural log base would just be ln, and so that derivative is kind of simpler. But log base, so when you can have any number base of a log, the derivative has kind of that extra little part to it. And those will be the formulas we'll put up on the board. Technically, the larger formula also works for natural log, so even if you get them confused, as long as you remember natural log is log base e will be good. I mean, like, yeah, Maddie.
I'm not sure what category this falls under, but number 2 in the review.
I definitely don't even know number 2 on the review.
Well, it's like a graph or like a chart form. So I can't read it all out.
Which review? The one from your packet?
Yeah.
So, are you doing number 2 from the table?
Yeah.
So that'll be similar to number 10 here. There's only going to be one of them on the test that has like table style values. I can read me number 2 and we can set it up even without the numbers.
Okay. It says let k of x equal g inverse or of x, and then what is k prime of 2?
Okay, so basically k represents the inverse. So we're trying to find the derivative of the inverse at 2. Is that part okay?
Yeah.
Okay. The formula for derivative of the inverse is going to be 1 over f prime of g of 2. Are we all right with that? Okay. Issue here is our formula, this g represents the inverse of f. Now, I think in that table, in the review, I think, doesn't it have 4 columns like f?
Yeah.
F prime, g, g prime?
Yeah. And then
G is the inverse of f? Is that what it says above it?
it doesn't say that, but actually, it just says assume that f of x and g of x are differentiable.
It doesn't say f and g are inverse?
There are like f's inverse and g's inverse, but I don't think f and g are.
Yeah, let me open up the review. Because unfortunately, a lot of the details is that. Assume that f and g are differentiable with given information.
No, because in the asterisk
Okay, so those f and g are not inverse. That's why I really dislike that g is frequently used as the inverse notation. So let me change the notation what I wrote up here so I don't thoroughly confuse you. So Sure. Since k is represented as the inverse of g, g is going to be like our main function, what we normally use as f. So in the formula, the regular function, the non-inverted one, would go right here in the front. So in this case, that would be g prime, and then this would be k of 2. This feels really weird to write. K of 2 is going to be something. Because k represents the inverse of g, then that means g of this something would equal 2. Because they're inverted, their numbers would be reversed. Their numbers would be inverted. And we're being told that k and g are inverse. So if you're looking in the table, you want to look under the column that's g of x, and then find where g of x has an answer of 2. So what is that? I put the table away.
X equals
1, okay. So then 1 is going to go in place of this question mark. K of 2 will be 1. The bottom of the formula is going to be 1 over g prime of 1, which should be directly in the table. 6. So then the inverse derivative at 2 is 1/6. By far, to me, the most confusing part about this is the letters they're using, I guess. And I completely understand that. Unfortunately, on the AP test, they frequently do similar things, where they'll start the problem off by defining what stands for what, and then you just kind of go from that info, which isn't great, but I believe on the test it's just written as F and to G and things like that, or in the beginning of the problem, it'll say G is F inverse. So it would kind of be standard notation. It also, while I bring this up, so on number 10 there, on the test, it says find the derivative using table function values. So not everything is going to be given to you in a table. I know you guys are probably pretty used to looking at tables by now because that's how you've been given the information. But tables are generally used when there's a lot of values. Rather than having a table, you very well might be just given information in function notation. So like you told me G of 1 was 2, so it would just be written in the problem like this. And then you said G prime of 1 was 6. So this would be how it would be written in function notation. It's not necessarily going to be a table. If you want, you could take this information and write it as a table yourself if a table makes it easier for you to follow. But know that that's kind of the difference between the notation. Yeah?
So we're going to be given either a table or those values like you have up there, not like an actual function and have to plug in numbers and stuff.
Correct, just for that one problem. Yeah, the other 14 problems are actual equations. Yeah?
Can you look at what number 11 is?
Find the velocity given the position function. Yeah. Let's just make up a position function, I guess. So S of t would be, so virtually every question on this test has chain rule in it. So the position and velocity equations are similar to what we did like in Unit 2, Unit 1. It's just going to have chain rule involved in the derivative. So let's just go with something straightforward like 3x squared minus 2 to the 5th power. And you might be asked to find velocity at 2 seconds, something like that. And it might be phrased differently, it might be whatever, but So in this case, you would do the derivative of position. And then it's going to be chain rule because we've got a group of things to the 5th power. So do you guys, I'm not sure what you want or need help on. Do you feel like you need more help on knowing what to do with problems? Do you feel like you need more help knowing how to do chain rule? Is chain rule coming somewhat naturally now, probably? Okay. So like on this one, you don't want me to kind of ask you how to find the chain rule? Should we save time to, okay, that's fine with me. So 5, I'm going to do the power rule to the 4th power times the derivative of the inside, which would be 6x. And then v of 2, I'm just going to plug 2 in. So the position and velocity question isn't intended to be like a, it's mainly just find the derivative, plug a number in. It's there to kind of refresh and keep it in your mind how they're related. Okay. Yeah, Maddie.
Finding the derivative of a log of
Whoa, which one are you looking at?
it's in the homework, but
Oh, that's, you can just give me the problem, that's
oh,
fine.
okay. Number 15 and 3.4. It's x or y equals x times 3 to the negative second x, or negative 2x.
Like that?
And then the 3 and the negative 2x is in parentheses.
Like that?
Yeah.
Okay. Just find the derivative.
Yeah. I was just confused on what to do when there's like something in front.
Oh,
Because there's a bunch in the homework like that, and the answer key's weird. It will like add to the front and add and like.
so I know what the answer key did, which is kind of odd, and it was done for a lot of them.
Yeah, I was like.
You don't necessarily need to.
Oh.
So the fact that I see a variable in the front and then a variable in the second tells me I'm going to have to use product rule. So first thing, second thing.
Okay.
And so I'm going to do first times derivative of the second. So derivative of any log, any number, any numeric base to a variable power, you're going to rewrite the exact same thing times the derivative of the power times ln of the base. And then we're going to do plus the second times the derivative of the first. And then traditionally for these, you're going to be expected to factor out common information. It looks like, oh, that's definitely all because the second one only has a 1. So this would say 3 to the negative 2x, and you'd be left with negative 2x ln 3, however you want to write that, plus 1. On the answer key, most of these, for some reason, and honestly, I've never seen it written that way before. So I know the answer key generally has things written in multiple choice style, but I've never seen you required to do this before. Is the answer key kind of took all of these numeric bases to a power and wanted to change them so that the power was just x. So it kind of grouped the numbers with it, and then it would write this as 1/9 to the x. So I know there was a different one that was 4 to the 3x. Quite a few people asked me this one throughout the day. There was one that was 4 to the 3x, and for some reason the answer key changed it to 2 squared to the 3x, and then evaluated 2 to the 6th, which is the same as 4 cubed. But yes, I don't know why it was written that way. I'm sure there was some intent, but you don't need to. I would be absolutely okay with this answer. That's kind of what I would look for. So you're mainly just to be expected to do something semi-obvious, like factoring out a common factor. You don't need to try to rearrange it and change it. That's kind of why we took off the multiple choice, was to make it go a lot faster.
Okay.
Okay. Otherwise, most of these are pretty straightforward. Most of these, as long as you're able to either know the formula or know how to fill it out, majority of the work is you interpreting the chain rule correctly, knowing when you need to use product rule. Yeah.
I got one more, number 15, the last one.
Okay. Second derivative with implicit.
Can you just go through a problem?
So do you have the review or anything in front of you? Because that one, if I make one up, it might work out really badly.
I don't know what question.
So it'll be phrased, it'll ask you to find d squared y over dx squared. They're very specific questions. Let's see, what section was that? I know there's one on the review, both reviews.
Oh, there's one in the homework.
Yeah, there should have been kind of scattered throughout all the sections.
Oh,
I have one from the homework.
Sure.
Yeah, just read it.
So 5x squared minus 2y squared equals 4. 181.
I'm guess the reason you asked this was just curious how to set it up type
Yeah.
thing. Okay. So these questions are kind of specific to implicit differentiation, which can be done anytime. So I'm sure most of them were in section 2 with implicit, but second derivative is kind of what it's asking. That's what this notation says. So we're going to do derivative of every term individually. So 10x, 4y, y prime, 0. And if I'm going too fast through any of this part, feel free to ask and I'll explain where things came from. Our goal is to solve for y prime. So I'd subtract 10x. Divide by negative 4y. What would that be? 5x over 2y? Why did I write squared? You guys are supposed to yell at me and that stuff. Prime. I don't even know where I got the 2 from. This specifically means second derivative. So I'm going to be taking the derivative of the first derivative. And it's quite a bit easier if you solve for y prime to do second derivative. I need to do quotient rule, so it's going to work out kind of ugly. So g f prime minus f g prime, which is going to be 2 times y prime over g squared. Now I could simplify this down if I want. The main thing on these that I'll be looking for, if you did or not, was you can't have y prime in the answer for d squared y dx squared. You specifically have to take this answer from y prime and put it in place of that. So that's the main thing on these second derivative ones to look for. So we'd have 10y minus 10x times 5x over 2y, 50x squared over 2y over 4y squared. I'm okay with this answer. I also know that a fraction and a fraction is frowned upon, but I don't want to take the time to simplify that. Sure.
Okay, you did 19 on the review. It's
9 on the review,
or 19.
19 on the review.
It's differentiate y is equal to sine inverse of the square root of 1 minus 9x squared.
Oh yeah, this one had a bunch of weird parts in the answer key.
Yeah.
The problem itself isn't horrible, but the answer key was. So, derivative of inverse sine is going to be, wait, let me pause. Do you guys like to identify u before you start these problems? Or do you just kind of go and fill stuff out as you go? Okay. If you're having trouble with them, that's one thing that may help, is to try to figure out ahead of time what would be like your u substitution. So if I'm doing sine inverse of u, it's going to be 1 over square root 1 minus u squared, which is kind of goofy, times derivative of u. So now I'm going to take the derivative of that square root. 1 minus 9x squared to the negative half times u prime. And I don't know if you were able to get this step correct. This is where most anybody who came to get help on this question, they had this, and then were really stuck how to figure out, oh, this one was multiple choice, wasn't it? Yeah. How to get to the multiple choice answer. So I guess I'll start simplifying. So square root squared eliminates the square root, but it's really easy to forget to keep that minus sign in the parentheses, because it's going to distribute out, the minus sign is going to distribute out. So that cancels out, but that becomes positive. Over here I'll simplify a little bit, so the 1/2 and the negative 18 will make negative 9x. I'll move this square root to the bottom. Okay, so this first thing has a lot of simplifying.
So the 1/2 inverse, yeah.
Oh, where the negative 9 came from?
Yeah.
Yeah, the 1/2 and the negative 18 together. So 1 minus 1 cancels. I'm left with square root of 9x squared. Square root of 9x squared, you do kind of individually. So square root of 9 is 3. Square root of x squared, we ran into this quite a bit in the limits unit. Yeah, when we were plugging infinity in infinite limits. So square root of x squared is absolute value of x. And I know the people that I was helping with this one, they just made it a regular x and then canceled with the x on the top. And I think that was a different multiple choice answer. And so that part could have been absolutely confusing. Yeah, this could be a problem on the test. The 3 and the negative 9 reduce. Negative 3 over absolute value of x. Yeah, it had a lot of simplifying. I mean, there's no doubt about that. Now, if you're worried about, I'm guessing what most of you are worried about is the simplifying. Possibly. Maybe not. I think Caden was. Here's what I'm looking for when I grade it. If you have this, if you have that step correct, that's a majority of all the points, because that means you did the derivative correct. Now, if you make mistakes in simplifying, that's going to be a minority of the points. So, in terms of being worried that this would be something on the test, I mean, of course I'm gonna have some hard questions on the test. It wouldn't really be much of a test if I didn't. It balances out in the end. So if you're doing well on the calc part, but having trouble simplifying, you know, that's about 80% of the points. And so if you make a lot of minor mistakes, you'll probably get about a B-ish, which is, I mean, it sounds kind of fair anyway. Any other particular problem you want me to do or talk about? I'll go back to the list. So since a lot of you didn't have a chance to look at this yet, did anybody start the optional review? I'm not going to pretend like this is your only class you're working on too. So I guess that was kind of my other thought. I didn't know if anybody would have questions from that one today. Would you guys like some, oh, I'm losing my voice. Would you guys just like some time to work for the rest of the hour to try to find questions you might run into? Because I'm okay with that too. I want to dedicate all hour today to answer questions. Normally I'd like to choose each one of these and say, what do you need to do to find this answer? But this test is pretty straightforward into what you need to do to find that answer, because, like, say, find the derivative of an exponential. Well, you go use the formula for an exponential function. And that work requires you identifying what u is and plugging in the right things. That's pretty much for every one of these questions.
I think it might be.
Yeah, Maddie?
Can I give you a problem?
Mm-hmm.
Or actually, I just had a question on it. When it's 5 to the 2t over t, would you do
Wait. 5 to the 2t,
over t? Would you do
like this?
Would you do? Sorry.
Like, what are we trying to do? Derivative?
Yeah, but
Quotient rule?
yeah.
Yes.
Okay.
So I've got variable information on the top, I've got variable information on the bottom. So that's exactly what the quotient rule is for. The only time you don't need quotient rule is if you've got a problem written like, I suppose I shouldn't have picked 5, but if you've got a problem written like this, where one portion of it is just a number, then you're not going to need quotient rule because you can write that number as like a multiplier, and then you wouldn't need quotient rule. But even if you didn't recognize that, you could do quotient rule on this one, it would still work. So theoretically, any fraction you can do quotient rule on if you're not sure. Okay, why don't I stop there? What was that noise? Somebody fell out a pass?
That might have been me.
Okay.
I wasn't here.
I just noticed when I was looking at the screen that there was a sound for notifications for the pass thing. I was just going to say, that's not my phone.
Do you mind if I-
Yeah, go for it. Okay, I'll stop there.